This is just to provide some quick tips for producing good graphics in this tutorial. That it will improve your graphics more than the number of tips taken. Okay, so for this first tutorial, that's the goal, is just very quick and easy things that you can do to improve your graphics. So the main points are to show the data. That's the fundamental purpose of using graphics. Is the data has to come through, or the model, whatever it is that you're going to show, is the most important thing. And then the key parts that I'm going to talk about in terms of things you can do to improve the graphics: background and grids, margins, color use, aspect ratio, and the use of ordering in making plots. Okay. Okay, so backgrounds and grids. The main purpose is to provide guidance without dominating the data gestalt, right? So the purpose is to get the sense of the data really fast. That's the reason why you make a plot of things. But grids provide a lookup to different things that you see in it. So the current recommendation, so all of this is based on different research that people have done recently, is to have a light grey background to your plot with white grid lines. And that allows your data to become pre-attentive, right? Pre-attentive means that what you see before you think about it. Okay, so what's the structure that you see before you actually get your brain engaged in it, right? And the importance of grids are to help you accurately read positions. People are very good at reading relative positions, but it helps if you really need to have the guidelines, but it's a secondary task to that. Okay, so both Cleveland and Carr have been the ones that have suggested this. This is commonly what people do, but the recommended approach is this style. Okay. Yeah, you can give your reactions. I think that's. Pardon?
I missed the board.
You missed the main reasons?
Well, it's just emotional. I'm so used to them. Yeah?
You're so used to these ones. Is that what you're saying? Yeah.
The frame around has disappeared. I think that's what you're saying.
Oh, sorry. Your frame's disappeared.
Yeah.
Right, but it's substituted because you've got an offset from the grey, with the grey background. So, I mean, you could still put a frame in, but if you've got a background color, then it's not necessary as much as it is here, okay? Because it sets off the data from the page, right? If you're probably far enough back, but the thing that comes through here is the points, right?
While we're being picky, I'd like the font on the axis labels to be the same as the font of the axis names.
This one here.
The ink color.
Yeah.
In other words, black.
Right, so there are some things. If you want to have this name faded off too, or you want to have
I want the numbers to be as a high contrast as the name.
As this one?
Yeah.
Okay.
Bright, not grey.
Yeah, there's a good reason for that. Is because that's not pre-attentive. And so you may actually argue that this should be a lighter shade too. What you want to see is the data, and that without thinking about it. To use these ones, you have to think about it. And so that's enough of a shade for you to come down and read those off, right?
Okay.
That's the purpose. If anything, it would be to change this to grey, but in some sense, these are also important aspects. That's not part of the work that I know of, but just that we have this background and the grids are faded out too, yeah.
I think it's okay if you look that on the computer screen, but if you want to put it in a paper.
That'll work in our current resolution, all right? So if you've got good resolution printing, this is excellent. The problem is if you're using photocopiers. So still, if you're using some old technology, that can be a bit problematic. So if you're photocopying this, it's not going to come out very well, and that is a problem with it. But if you want people to see your data and get the message fast, that's the approach. Okay. Just a slightly different example. The time series. This is not all about scatter plots, other sorts of plots as well. And another reason for that is that it gives the plot the same weight as the text on a page. Okay, so if you squint at this, and you see both, they're sort of roughly similar grayscales. So the plots get the equal weight, and it sets a plot apart from sitting on the white page as well. Okay. Alrighty? Move on. Okay, margins. This is kind of an old thing that seems to have been forgotten, but work that Cleveland did is outside the box, the picture, there should be a 5%. So this is one of the problems is these are not defaults of most software, but if you don't have a 5% margin, points in the extremes get lost. People forget about them. So that's really an old thing that really needs to be brought back to people's attention. You need that 5% of extra space. It's kind of hard to do sometimes. Okay, next one, color use. Color is the most pre-attentive graphical element. People react to color before anything else, pretty much. It's pretty well known. Critical thing these days, because it's easy, is we need to make sure that plots are color blind proof, and you still see examples where they're not. But there's no excuse today because there's a couple of nice tools for selecting colors and one for checking your graphic to see how it would look for a colorblind person.
Naughty, what fraction of the population is colorblind?
I don't know, a fair percentage. I don't know exactly, but I run into them all the time. Yeah, I don't have that percentage, but you have a room here with 40 people. There's probably 1 or 2 colorblind people. Yeah, it's a significant fraction. Several of my colleagues have colorblind people in the department. And Color Brewer is work by Cynthia Brewer, where she's got recommended color scales that she's done a huge amount of testing on. The problem is that she's a geographer, and so these are good selections for large swatches of color, but it doesn't work so well in many of our stat graphics. Okay, so we tend to choose in different colors. VizCheck is a website that allows you to check your plots for how they would appear to a colorblind person. So you can upload your image to that web page. Just vizcheck.com. And so I uploaded this picture. I mean, the classic example. Red and green is such a beautiful color combination for us not colorblind people. This is how it would look for a colorblind person. So that's what comes off the VizCheck page. It's really fast. You just load it up, goes. So it's really fast to check all your graphics. We did every picture in our book, and there were like 200 pictures. Really easy. Okay? VizCheck's a nice thing to know about. Another thing that people often, all the default of software is to have a rectangular plot aspect ratio. That's typical. If you're working with multivariate data, it shouldn't be a rectangular aspect, it should be 1-to-1 because the variables should be equal weighted, given equal weight, right?
You're distinguishing between a bivariate plot where there are just 2 variables and general multivariate plots, are you?
Any 2 variables if you're thinking about multivariate analysis.
Yeah, if I only have 2 variables, then you're.
I mean, if I'm looking at the bivariate relationship, I'd still do this. It's just if you're thinking about making a regression, people tend to do this. You've got 2 sets of variables, and so it's okay to treat them differently, right? But if you've got 2 variables as part of a bivariate data set, then those variables should have equal weight. Okay, ordering. It's amazing how useful reordering your data and plots can be, and how easy it is to ignore and forget about it. But how you order your data allows you to read off things, allows the reader to read things much easier and quicker in different ways. All right. So one of the problems is that data often comes with no specific order. Some graphical displays rely on order, and so even if it's not ordered, you need to do something. But it's very useful to think about ordering according to some statistic value calculated on some of the variables, like the average of one column or the total of a column, the cluster mean. The classic example is this one by Dan Carr, when shifting from looking at tables to plots of it. In government statistics, we have tables and tables and tables of numbers. This is a typical example, and the classic ordering is alphabetical. Alabama, Alaska, etc. Right? That's okay for bookkeeping if you really want to go back and look up which state, like what are the numbers for Alabama. But if you try to communicate the information in that, it's useless, right? Yeah, I'm sorry.
Oh, you poor person.
I think it shows up here. This is a reordering, and what's the main message that so reordering that same data, it's actually reordered by this column. This is toxic waste. It's a toxic resource inventory. First message, Texas and Louisiana are big polluters. Right? That just jumps straight out. Okay, so Texas can't hide anymore. And then the other ones are reordered in the same way as this, which means then you can look at sort of the deviations from that pattern. Like Florida and Pennsylvania, big land polluters. That's this column, right?
So what is the R command for this sort of?
That one's a bit of a difficult one for that one. So it's just sort of a teaser. Yeah, let me get to some of the R commands later. There's a slightly simpler example. This is data that I've been working with for an ecologist. Here's how they usually display their data. So it's just alphabetical of species. Okay. You really can't see very much. The important thing is to know what the abundance is of the species. So ordering according to the mean or the median or something allows us to read off the top. And I don't have the R command for that, but it's basically factors. So for each of the different species, I calculate the mean, and then I use the factor, set the levels according to the order of the species. So it's not too hard to use, although working with factors can be really a pain in R. Yeah. But you just need to change the levels and then it comes out from that. All right, so I'm going to then get into some R code. This is going to be a real short session today. So if you want to get plots reasonably fast with general good defaults, Hadley Wickham has produced this package called ggplot2, and it comes with multiple layers, but basically the defaults are what I've talked about earlier. And the easiest entry is the function called qplot or quickplot, which works just the same way as the plot commands. Same sort of syntax. The full-blown version is a function called ggplot, which is a full grammar of graphics. So it allows you to compare different sorts of graphics through a grammar and build complicated plots. So I'm going to run through a couple of those. So if you just want to do a very simple plot, qplot x, y, data frame will generate, that's your default plot. Okay, pretty easy. Yeah, I did have some code in here. So if you want to do something a little bit more sophisticated, still much of it's the same. Quick plot, x, y. I'm putting the transformation in here, but I could also put a transformation elsewhere. So I'm logging the count variable. Here's my data frame, and I want it to do both points and a box plot, so I can overlay two different geometries on there. And this last one, this is slightly more sophisticated. This coordinate flip changes the direction of the plot. So you can do quite a lot with the quick plot, but if you want to have a lot more free range,
there's some implicit understanding that the box plot overrides the points.
Depends on the order. So yeah, if I put it the other way around, the points would override the box plot. Yeah. Okay. If you want to do something a lot more sophisticated, ggplot would be the thing to use. I'm going to do is build up a plot in multiple layers. And it's also going to allow you to build up plot templates and plug in different data to it. This is a little bit tricky just in itself. This is data on just temperatures really for South and Central America, latitude, and I've got those wrong. I put these labels in myself, overrode the data, and it's long and lat are mixed up, right? Yeah. So at each of these long and lat and longs, we have time series of temperature.
Over
and
what
now,
time period?
Over 6 years. I think there's monthly data for 6 years, 72 measurements of temperature. And the area is in Central America. I don't know whether you can recognize sort of some of the land outlines. Not really.
Is that sort of the coast of northern, southern South America? Or
Yeah, you got it. You got it. But we don't like to guess things. Anyway, let me give you the commands for doing that. So, I'm starting off with ggplot, but adding a layer. So there's nothing in that particular function, just to tell R that you want to use the ggplot package here. But I'm going to specify the first layer more explicitly. All of these things could be put inside the ggplot function as well, but I want to spell it out a little bit more explicitly. So this first layer has expo data. I'm mapping long. I had to do a little bit of calculation myself to get those time series laid out. So the x is the longitude plus 2 times some time factor, so it spreads out the time series. And the y direction is latitude plus 2 times the temperature. That's allowing me just to get those little time series at each location. The transformation, statistical transformation, is just the identity. I'm not doing anything strange there. Just spell it out. You don't need to spell it out if you're using the default, but I'm using a point geometry, and I'm changing the size of the points, making them fairly small. I'm setting the axes very explicitly here, scaling the x and y axes. This is where I've messed up the labels. I explicitly put labels. Hi, long and lat, which should be reversed. That was my dumb mistake. But it allows me to set limits and breaks for the tick marks on the axis, which can be tricky. And R doesn't actually do anything until you tell it to draw. So this is an abstract form, and you have to say draw it. So I've saved that whole thing into a data structure. Right, if I want to put a second layer in, like the outline of the map, right, then you can see you're right in that bottom of the USA and the top of South America. Right, Mexico, Nicaragua and Panama, I guess. There's a couple of interesting things about the temperature measurements, you can see, right? I mean, this is beside the message of the graphic, but there are really some quite interesting things about differences in temperature for that region. There's something that really jumps out.
Warming on the west coast.
Actually, that's up in the Andes. Yeah, so all along. And again, there's a bit of it up around Mexico and the mountains in Mexico too, a little bit. Okay, so overlaying a map. Again, it's just a very complicated example, so you see some of the more difficult things that can be done. All right, so what did I do? I think I went backwards. Okay. I messed up the code on this one. So it's supposed to be a very informal presentation, and I messed up the code. So I can show you the third layer. All right, so third layer, maybe I want to put some regression lines on each of those as well, or show something else, so add a different line. What I have in order to do that, I've got another data set, right? So each of these layers could have different data sets. That's the map one had an outlines of the coast and countries. So that was a second data set. This is a third data set that's being overlaid, which is the regression model. Again, the only thing that actually changes is I'm showing the predicted values in the vertical axis. Changing the data set and using a line geom and setting the color to be that. Okay. All right. So that's actually all I have for today. It was a nice short session. Just summarizing those plot aesthetics. There's a few different things that you can do to dramatically improve your plots: the background and grids, margins, color, aspect ratio, and ordering, critical pieces. There's quite a lot of tools to help out with that. ggplot2, our color brewer, and VizCheck. ggplot2, more information is available on that webpage. And next week I'm going to show you more about looking at data in high dimensions, or looking at high dimensional objects. Okay? So I don't want to take too much of your time.
So the recommendations, are they sort of universally agreed, or say, for example, Tufte says all sorts of things in his books?
Right.
And what's the status of those?
So, it's not a matter of preferences. Things have got beyond, I like this, I don't like that. There's, Cleveland is probably the one that's done more studies. There's still not enough studies, but Cleveland and Carr, not particularly rigorous studies, but just in terms of this background of grey with white grid lines, that's sort of the accepted norm now.
Can you go back one from this?
This way?
That's actually a very good presentation, I think, that one.
This one.
And that's not, and you said that's actually not a standard thing to produce, or it's a tricky thing. You said the code's a bit tricky.
Yeah, it is a bit tricky to do. Yeah, so I actually generated each of these separately, each bar chart separately.
I mean, if the statistical abstract of country X was presented that way, I think you'd be a long way further along.
Yeah. Yeah, I mean, you can't easily hide if you're presenting the information this way.
Well, that's true, but I'm sure that the people who develop the abstract don't think in terms of hiding stuff. It's just that that's the way they presented it for 150 years.
Yeah. Yeah, there's a difference in terms of archiving information and communicating information, and this is a communication.
But for, if there's, if you have a web presentation of the information, then of course you can, mouse over the bar and get the actual number, right? So.
Exactly. All right. So yeah. So that's a different point in some way. This is a presentation graphic. You basically know the patterns that you want to that you're in the data and you want to communicate. In that situation, you can create very nice things tailored to that particular message. Generally. In that framework, though, if you have a lot of data and you want to present all of it, having something interactive overlaid on that can allow you to communicate a lot more information. And as you say, if we had some interaction available on this plot, one obvious thing you'd want to do is be able to mouse over and get actual numbers sometimes, yeah.
Right. When they
or
select,
resort.
There's clearly some sort of presentation thinking that is going into deciding which tables to present in something like the statistical abstract. So they've sort of done half the thinking, and somehow doing this as the finish of the presentation would seem to be a natural thing.
Right. Yeah. Okay. Well, again, thank you for coming. No need to clap or anything. It's just a tutorial, right? So.